Hello, Dr. Stram. Okay.
Hello.
Can you
Nice
hear
to
me?
join here.
Okay, good.
Yes, I can hear you. Yeah.
Yeah, thank you very much for your attending for our forum. So wait a moment. At first, I would like to explain on this presentation, and then after the presentation of Esra, and then you can answer some Q&A. Okay? 우선 이 경위를 좀 말씀드릴게요. 저희들이 오늘 이 발표할 분은 이제 독터 에스라 큐크피나라는 분이고, 그분이 이제 지난달에 저희, 에버캠텍 그 자체 세미나에 오셔가지고, 발표한 내용을 오늘 녹화 방송을 이제 여러분께 좀 드릴 거고, 거기에 대한 질의응답을 그 큐크피나 박사님의 부서의 이제 부서장님이신 이제 독터 코르넬리아 슈트란 박사님이 거기에 대해서 질의응답에 응해 주실 겁니다. 일단 그 발표 자료를 녹화본을 제가 미리 좀 공유를 해드렸기 때문에 그거 좀 틀고 나중에 질의응답으로 가시면 될 것 같습니다. 그리고 그에 앞서서 이제 프라운호퍼 연구소에 대해서 간단하게 설명을 드리면요. 프라운호퍼 연구소 자체는 총 분야별로 약 한 76개 연구소가 독일 전역에 있습니다. 그리고 연간 연구비 예산은 한 5조 원 정도 되는 큰 연구소고요. 우리나라 생산기술연구원의 그 벤치마킹이 되는 그런 연구소입니다. 그리고 오늘 이제 두 분이 속해 있는 프라운호퍼 IVB라는 곳은 이제 독일어인데 Institut für Verfahren und Verpackungstechnik이라 그래가지고 가공하고 식품 가공하고 그다음에 이제 포장에 대해서 전문적으로 연구를 하는 곳입니다. 이제 독일 뮌헨 근교에 이제 뮌헨 공항이 있는 프라이징이라는 곳에 위치해 있고요. 그 연구원들은 한 350명 정도 되고 연구비 예산은 연간 한 600억 정도 되는 어떤 사이즈의 연구소입니다. 그래서 여기는 뭐 다양한 포장재, 식품이 만들어지고 포장되고 그 포장재가 재활용되는 것까지 전체적인 과정을 연구하는 연구소라고 보시면 되고요. 오늘 저 소개드릴 분은 재질 개발, 포장재의 어떤 재질 개발에 있는 부서의 이제 부서장님이 되시는 겁니다. 예, 이상입니다. Institut ist vorgestellt. Dann.
Okay.
Hi, my name is Esra Kücükpinar. I am working as a scientist at the Material Development Department of Fraunhofer IBB. I will now present you the circular plastics part. So, flexible packagings are made of plastics and they are low cost to produce them, easy, lightweight. However, they consist of several different types of layers, materials, and it is very difficult to recycle them. So currently 70% of the packaging materials used within EU is from flexible packaging, and there is no infrastructure to recycle them, especially when they consist of several different types of materials. So there is the new regulations now, packaging and packaging waste regulations that have been in action since last week, Monday. And according to these regulations, the flexible packaging materials need to be recycled. And in some years, in 2035, their recyclability should be at scale. And in addition to that, there are also the requirement of integration of post-consumer recyclate content within the packaging materials. And here you can see in the table, for the case of polyester-based packaging, for example, the requirements are higher than the case of the non-polyester-based packagings. When it is PE or polyolefin, the content is less than that of polyester because it is easier to clarify to produce clean polyester recyclates in comparison to polyolefins. And the contact sensitive packaging means the food packaging or, for example, also personal care packaging. So that is going to be a challenge. So first I will introduce you how to design new materials that are recyclable. Currently, most of the flexible packaging materials consist of polyester, and then it is coated with an inorganic barrier layer, and then it is adhesive laminated to a sealing film. So these kind of structures that consist of several different types of materials are not recyclable. One way to make them recyclable is to go to monomaterial systems. So for example, here in this picture, you can see one of those examples, which is based on polypropylene. So there is the BOPP substrate. It is primerized, and then an inorganic barrier layer is applied on top, and adhesive lamination, and then a sealing layer. So it consists of around 90%, more than 90% polyolefin, which makes it easier to recycle in comparison to its multi-material counterpart. One other approach that we are following within our department to make these recyclable structures is the application of nanocomposites. We have developed a new barrier structure within the last 5 years. You can see here the publications by Stefan Schiessel from our group. We integrate some platelets into the lacquer, and this extends the permeation pathways of the gas molecules, and by this way we incorporate barrier performance. This lacquer can be applied at atmospheric conditions on a polyolefin-based substrate, and when it is laminated, again, for example, with the polyolefin-based sealing film, we get a monomaterial solution. So, having said these concepts, I would like to show you what we did in one of our openly funded European projects, Flex Function to Sustain. Together with the Capri-Sun, they produce drink pouches. We have developed a new recyclable material. So their material is not recyclable, so it consists of polyester, aluminum, polyethylene, which makes it impossible to recycle. So we have designed with them 3 different monomaterial recyclable solutions. One of them consisted of the metallized layer, the other one consisted of the silicium oxide layer, and the one of them consisted of the nanocomposite layer as barrier. We have sealed these coated layers to the sealing layer cast polypropylene. And after that, we have measured their barrier properties, mechanical properties at our institute, and also Capri-Sun has characterized these materials regarding their, for example, vitamin loss or taste loss, or also light transmission performance. And their properties were all suitable for their application for drink pouches. And also, we have characterized their recyclability. We shredded them and then compounded them and then produced pellets, and we produced films and looked at their mechanical properties, optical properties, and all these 3 structures were found to be recyclable. And now the drink pouches of Capri-Sun company are recyclable, and they are based on this metallized solution, monomaterial PP. So there are several different other applications that we have introduced these monomaterial-based recyclable solutions into tray lid systems, for example, or bag-in-box systems, pharma blisters, and cosmetic tubes. Here you can see the QR codes. If you can access these sites, then you will see how we design these novel structures and characterize them. So after monomaterial-based designs, the other challenge is the integration of the post-consumer recyclates. So these monomaterial designs should be actually also be prepared for the integration of post-consumer recyclates. The challenge here is that the production of the post-consumer recyclates, they need to be really with high purity for their application in food packaging, and also they need to fulfill the requirements of the applications, flexible packaging applications. So according to the European Food Safety Authorization, the post-consumer recyclates are applicable in food packaging applications only if they are produced using the food packaging items. Since there is no closed-loop system in flexible packaging, there is no possibility to include post-consumer recyclates in flexible packaging applications for food. Therefore, we have initiated a project around 5 years ago so-called circular packaging for direct food contact applications with the acronym Circular Food Pack. And this project included 15 different partners from 7 different countries, and Fraunhofer IBV coordinated this project. This project has just been finalized at the end of 2024. We had in the consortium the waste collection company, Suez, for example, as a converter company. We work closely with Amcor. Also, ink producer Sigwerk was involved, and tracer producer for sorting Polysecure was involved, and at the end brand owner was Nestle. And therefore we have initiated this project, Circular Food Pack. Here in this slide we can see the objectives and also how we implemented the project. Everything starts with sorting. We wanted to separate the food packaging items from the mixed household flexible packaging waste to recycle them so that the produced post-consumer recyclates can be included into the food packaging items again. So after sorting, the separated food packaging items have gone through different pretreatment steps like decontamination, like de-inking. We have followed 2 different types of recycling in this project. One of them was the dissolution-based recycling, and the other one was the mechanical recycling. And then all these recyclates were tested regarding their food compliance and safety. We have, if the safety requirements were not achieved, we redesigned the packaging materials so that we can include these post-consumer recyclates using some functional barriers. And at the end, using these final structures, we have produced demonstrators. So here you can see the flow of the one small implementation of the project. So tracers were included into the inks of the packaging materials, and then it was possible to sort out the food packaging items from the whole collected packaging waste. Then the contamination de-inking process was applied at the Uganda University, and Fraunhofer IBV has applied the dissolution-based recycling technology. And then the recyclates were then checked regarding their compliance properties, and they have been reintegrated into the newly designed structures. And then these new designed structures were used for the production of packages, pouches for food and non-food applications. And then a second cycle had started, and we have performed 2 different cycles with the same input material. At the end, the recyclates are, of course, all the times characterized. Here you can see the mechanical properties of these recyclates. The mechanical properties were very similar to their virgin counterparts. However, the problem is the integration, their integration in food packaging. The contamination levels were not sufficient. Therefore, we needed to include functional barriers. We have screened several different types of functional barriers. And here you can see 2 of them were below the specifications required, and therefore we use these functional barriers. And we designed 2 different structures. On the left-hand side, you can see the triplet structure, which includes the post-consumer recyclate in between 2 barriers. One of the barrier is the machine direction-oriented polyethylene, primered and Ciox-coated, and the other one is a sealing film, polyethylene EVOH polyethylene. By this way, we reduce the migration of the contaminants from the post-consumer recyclates towards the food, and also we eliminate the cross-contamination when the film is winded on a roll. So therefore, it worked very well, this triplet structure, for their application for food packaging. On the right-hand side, you see a duplex structure. Here, we had the possibility to increase the post-consumer recyclate content at very high levels because we managed to integrate it into the substrate, so machine direction-oriented PE, MDO PE, and also into the sealing film, because here we didn't have the issue of the food contact application. The duplex structure has been designed for the non-food packaging applications. And here you can see the demonstrators that we have produced at the end of the project. From left to right, it is the coffee packaging, cocoa packaging, espresso packaging, together with developed with Nestle. And on the right-hand side, you can see the wet wipes and then the detergent tabs packed in stand-up pouches. So in the case of the food packaging applications, we increased the post-consumer recycle rate up to 30%, and for the case of the non-food packaging applications, the post-consumer recycle rate was up to 62%. So this was quite a success. By this way, at the end of our project last year, we have shown that, hey, packaging and packaging waste regulations are challenging. However, it is achievable using the physical recycling technologies, including de-inking, deodorization, compounding, pelletizing, and with the functional barriers, we made them applicable for food packaging. And also, of course, the research has to continue still to upscale these materials more and to look at their reproducibilities. This brings me to the end of my presentation. Here you can see our team, Material Development. We are around 30 people, including scientists, technicians, and engineers. The department is led by Dr. Cornelia Stram. And we have tried to show you today some of our research topics and research results. And if you have any questions, we would be very happy to answer you. Here you can see our contact details. Thank you very much.
네, 감사합니다. 박수 한번 부탁드리겠습니다.
녹화 방송이기는 하지만 그런대로 이제 현장감이 좀 있었던 걸로 생각을 합니다. 혹시 질문 있으시면 해주시면 좋을 것 같습니다. 그리고 뭐 영어가 가능하신 분은 직접 영어로 질의를 하셔도 상관없습니다.
근데 실제상으로 저 내용을 좀 보시면은 지금 국내에서는 이제 대부분들 연포장 플렉서블 패키징이라 하죠. 요 부분들은 재활용성이 떨어지기 때문에 대부분들 이제 소각을 하거나 재활용은 거의 불가능하다고 생각을 합니다. 근데 지금 요번에 이제 발표된 내용을 보면은 그러한 멀티레이어 돼 있는 것들을 다시 리사이클을 해서 다시 이제 멀티층에 쓰여지게끔 이제 중간에 베리어층을 놔서 그 부분을 검증을 했다라는 게 상당히 큰 의미를 갖고 있는 요번에 연구 내용을 요번에 이제 에즈라 박사가 이제 발표를 한 거였습니다. 그래서 그 부분에 대해서 좀 내용이니까 궁금한 점 있으면은 말씀을 주시면 좋을 것 같습니다. 코멜리아, just I would like to ask one question. Just as I'm explaining about the R&D as content, just the new composition of recycled as flexible as plastic waste from flexible as packaging. Usually is we have to 지금 이제 그 설명을 했다고 얘기를 했습니다. 그리고 at this point it's very important to think that is very safety for the food packaging. So then usually in the as multi-layer as packaging, just to prevent the permeability of the bad as a component as to when we recycle the flexible packaging. How can we use what kind of thing what kind of the barrier layer as can be used for as preventing such a permeability of the bad as components. Can you explain the key points of the barrier? The layer technology?
Yeah, I hope I understand the question the right way. First question, can you hear me?
Yeah, just the first question is
okay.
Yeah. Then is
okay.
How can you prevent the permeability of the bad as component from of the recycled waste as a flexible packaging? Esra's speech, we can see the barrier technology as when the recycled packaging is used in the layer packaging again. Then can you explain about the key points of technology of the barrier, the layer, to preventing such a bad component is the permeability.
Yeah, you're pointing out the functional barrier, and therefore we need this barrier layer to protect the sensitive foodstuff against migration on things the polymer catched up during the recycling process. And here we tested different materials as functional barrier, different adhesive, different lacquer systems, and also inorganic coatings like aluminium or silicon oxide. And as in the column you saw, we received different results and the protection. And so it depends on the amount you have to protect, you have to reach. And also then on the application you want to pack, how sensitive is this material. One main outcome was that a co-extrusion of recyclate with a virgin material is not sufficient to protect the foodstuff with the functional barrier. You need a separate coating step to integrate this barrier layers.
Okay.
Was this the question?
Yeah, it's just I can understand that just usually the inorganic as materials layer is mainly is used for the such a protection.
Inorganic,
Yeah.
but
As
also
a silicon oxide.
Yeah. Silicon oxide, but also barrier lacquers, acrylates, or the lacquer with the platelets. Esra mentioned also before in her presentation. There are also lacquer systems available. They have comparable results to inorganic layer, so that you can avoid the vacuum process. So there are both possibilities.
Yeah, such as a barrier and the vacuum system can remove the such the bad component is from the recycled material. Two method is a combination in the extrusion.
No, it's not a combination. You can decide, but co-extrusion, it's not sufficient. But you can choose between inorganic layer and organic lacquers. Both barrier systems are possible for this functional barrier. So because you asked for the barrier technology, so it's barrier lacquers based on solvent-based organic lacquer systems or inorganic coating systems. These are the barrier technologies you can use as this functional barrier.
Okay. And then I will ask the additional the explanation as about as my question. And I will send it to you is email. Then I will give questions to you again. Okay. Thank you.
Yeah, you're welcome.
Yep. 다른 좀 질문 사항이 있으십니까? 예. 예, 그것도 있겠네요. Can you explain about the removing system of the ink as where the such a printing is a residual as material? Can you explain that technology?
So not in the details. So the University of Ghent developed together with the company Siegwerk here a washing process to remove the inks. So they developed different temperature profile, water amounts, but also they try to use primer before they put the inks on the film. Before they apply the inks on the film, they put a primer on the polymer to better remove the inks from the polymer films. This was also one step. This was mainly the work of the University of Ghent and the company Seekwerk. But it's the main point for the quality of the recyclates to remove the inks. It's very important to find here solutions in the recycling step to get rid of the inks.
주로 이제 이제 프라이머에다가 이제 잉크 필름을 담궈가지고 그 부분을 1차적으로 이제 제거하는 이런 공정 부분이라고 지금 설명을 했습니다. 좀 자세한 부분은 저도 이제 조금 더 디테일하게 저도 궁금한 부분이었기 때문에 그 부분 좀 더 디테일한 디스크립션을 좀 받아서 드리도록 하겠습니다. 그 명함을 하나 주시면은 그 부분에 대해서 좀 알려드리도록 하겠습니다. Okay, so we can understand approximately as your explanation. Then as a letter, I will ask you again the detailed explanation as such a removing is technology and the process. Then that is the point. Very important. Very so much. I wondered also the so much. Then as I will inform you. Okay.
Okay.
Yeah, thank you very much. 또 다른 질문이 있을까요? 네. 미스터 성함이 코르넬리아.
Cornelia.
Yeah, Comelia. Sorry, just
Yeah, it's
just
a difficult name.
next time, just the director is I would like to meet you. Yeah, then it's Comelia. Thank you very much for your joining together. Just even if the Esra gave the speech, but just I'm very glad to see you even this Zoom meeting. But just thank you very much. You can say to the Korean audience, you can say goodbye. Just you can do.
Okay.
Yeah.
Thank you for joining and for the possibility to present our research results. And please, for questions, send us an email. Enjoy your meeting. Bye.
Yeah. Thank you very much.